Imagine sitting in your room, looking at the night sky, and realizing that we're no longer just stargazing. We're actively building a future among the stars, preparing rockets that roar through Earth's atmosphere, building space stations that orbit our planet like floating cities, and even planning the next great leap of humankind. Colonizing Mars, the dream of space travel ever since the first human looked up at the stars and wondered what lies beyond. We've been driven by an insatiable curiosity to explore the unknown, to go where no one has gone before, and to turn science fiction into scientific achievement. And now, for the first time in human history, space travel is no longer the realm of dreams, but a reality unfolding right in front of our eyes. How rockets actually work. At the heart of space travel lies the mighty rocket, a towering pillar of human engineering that uses controlled explosions. Yes, explosions, to break free from Earth's gravity. Because on Earth, gravity holds us down with a force that requires an incredible amount of thrust to overcome, and rockets achieve this using Newton's third law of motion. For every action, there is an equal and opposite reaction. In simple terms, a rocket engine burns fuel to produce a high-speed jet of gas that blasts downward, which pushes the rocket upward into space, and this fuel is usually stored in two stages. One for the initial liftoff, and another for pushing the spacecraft further once it's already in the upper atmosphere. Today's rockets, like SpaceX's Falcon 9 or NASA's Space Launch System, are reusable, efficient, and far more advanced than the early rockets that powered the Apollo missions, reducing costs and making space travel more sustainable for future generations. Breaking through Earth's atmosphere. To reach space, a rocket must travel at about 28,000 kilometers per hour. Yes, that's right, nearly 8 times faster than a speeding bullet. And it has to pass through the Earth's thick atmosphere, battling friction, heat, and pressure, which is why the design of a spacecraft's nose cone and thermal shields is so critical to surviving the violent ride upward, and later, the fiery re-entry back to Earth. Once it escapes Earth's grip and enters orbit, the spacecraft can finally float freely in the weightless vacuum of space, where time slows, silence reigns, and gravity no longer dictates motion. Life in space. The IST, one of humanity's greatest achievements in space, is the International Space Station, a giant orbiting lab that circles the Earth every 90 minutes, allowing astronauts to live and work in space for months at a time, conducting experiments on everything from plant growth to human biology in zero gravity. Living in space isn't easy. Astronauts have to exercise daily to prevent muscle loss, sleep strapped to walls to avoid floating away, and carefully manage limited supplies of water, oxygen, and food. But every challenge they overcome brings us closer to building permanent settlements beyond Earth. Why space travel matters. You might be wondering, why spend billions on space when we have problems on Earth? But space travel has already given us satellite communication, GPS, advanced weather tracking, and medical breakthroughs, not to mention the priceless knowledge we gain about our planet, our solar system, and ourselves. More than just science, space travel represents hope, innovation, and unity. A shared mission for all of humanity to work together, push boundaries, and discover what lies beyond. The engineering behind interplanetary travel. Traveling to space is hard, but going to another planet like Mars is even harder, because it's not just about distance, it's about surviving a 6 to 9 month journey through radiation, microgravity, and isolation, and then landing safely on a world with a thin atmosphere, extreme cold, and dust storms that can last for weeks. Engineers are developing spacecraft like SpaceX's Starship and NASA's Orion capsule, which are designed to carry humans beyond the moon and into deep space, equipped with powerful engines, life support systems, and protective shielding to withstand the harshness of interplanetary travel. The key to making this work is fuel efficiency, autonomous navigation, artificial intelligence support, and the ability to generate resources like oxygen and water during the mission itself, using the environment of the destination planet, a concept called in situ resource utilization. The Artemis program and return to the moon before we reach Mars, we're going back to the moon. This time, not just to visit, but to stay. Because NASA's Artemis program aims to establish a long-term lunar base that will serve as a stepping stone for future missions to Mars, allowing astronauts to test habitats, systems, and equipment in a real space environment just 3 days away from Earth. The moon will become our training ground, our launch pad, and our proving ground for deep space exploration, helping us build the skills, infrastructure, and confidence needed to make the giant leap to Mars. Mars, the next frontier. Mars, our red neighbor, dusty, dry, and distant, has long fascinated scientists, storytellers, and explorers because it's the most Earth-like planet in our solar system and potentially capable of supporting life. And now, for the first time, we're preparing to send humans there within the next 2 decades. Colonizing Mars will be the most ambitious project humanity has ever attempted, requiring habitats that can shield against radiation, greenhouses to grow food, robots to build infrastructure, and possibly even nuclear reactors to provide long-term power. The Martian environment is hostile. Cold temperatures, thin air, no breathable atmosphere. But with the right technology, determination, and international cooperation, humans could build a second home on Mars, one where future generations may be born, grow up, and look back at Earth as their ancestral world. The role of private companies. Space exploration is no longer driven by governments alone. Private companies like SpaceX, Blue Origin, and Rocket Lab are revolutionizing how we access and use space, lowering costs through reusable rockets, increasing competition, and accelerating innovation at a pace never seen before. And daring to ask the biggest questions of all: who are we? Where did we come from? And where are we going next? The stars are no longer out of reach. We're going. We're building. And soon we may call more than one planet home.